Now, we're going to put some meat on the bones of the skeleton for homework 1. Now, we did this for our test run, but I'm going to go over it again. So I'm going to go over into the modules on the left-hand side because I know all the content is organized by unit and chapter. Come down to the first chapter, Exploratory Data Analysis, Homework 1. So in all the homeworks, there will be some download files. They're almost always going to be the same exact Excel file with Eno's dataset. Download that. And the R code, the RMD notebook file. So in Chrome on Windows, when I download them, they show up at the bottom, but it also puts them in the downloads folder. So if I come to my downloads folder, I am now seeing the chapter 1 assignment skeleton. That's the blank outline. We just need to put the meat in. We've got to type some things in to make it do what we need it to do for the homework. And we have Eno's data set. Now, both of these are downloading, if you look carefully at the names, with a -1. That's important when we go to read in the data set. So now that I have them downloaded, it automatically downloaded in my downloads folder, which is great, but I probably don't want to work out of there all semester. So I'm going to come over into my documents folder and make a new folder. And I'm going to call this, I can call it EDUC 6600 for Education 6600. And I'm going to put all my files for the class in there. So I'm going to go back to the downloads and I'm going to take both of these files and I am going to cut them so I can go paste them into my 6600 folder. Paste. Now, it would probably be a good idea. I mean, I know in class I said you could do separate files, but every chapter is going to have a different assignment, an RMD component, except for one on Power. But they're all going to use the same Eno's data set. So if you want to put all your homeworks in the same folder, that would work fine for this class. So I'm going to double click on the name of the RMD file and it should open it in RStudio. Now, I'm going to make this font a little smaller. Now, to change the appearance or the font, we need to go to Global Options. In Windows, it's under the Tools menu. In Mac, it's under the Windows. There's a window option right there, but at the very bottom, it'll be Global Options. Then I can click on Appearance, and I'm going to change, 110%. I'm going to go to 10% and or 100% so that it's not so big. If you're wondering, this is the editor theme that I'm using. Okay, that just makes it a little smaller. Okay, so we already went through in the directions video how to knit this to make sure that everything's running fine. And always it's going to say your name. So please always change this to your actual name. And change the date, whether you want to put the full date or just spring 2021, or you can do January 26th, whichever you want to do. That's today. All right, so I'm in the process of, it's taken a second, knitting, there we go, the PDF. This PDF is just the skeleton, the bare bones outline for you to work with. And again, these questions or these components are coming out of our textbook, the Barry Cohen Explaining Psychological Statistics, 4th edition. So all of the things that I'm asking you to do in the homework come out of the section C in each chapter. So if you have the textbook and you can open to chapter C or chapter 1, part C, and you'll see all of this is in here. So it explains Eno's data set. And then at the end of the section, there are 5 problems to work out. 5 or 6 of them. I've transposed this into the R skeleton, the R markdown skeleton with the .rmd. I'm also taking information about Eno's data set is in Appendix C. So in Appendix C of your textbook, it actually has the whole data set printed out, which I have in Excel. And then it also has a data dictionary that says what the variables are and how they're coded. So we're going to use that information. So You don't have to carry the book around because I typed it all in here. So the first things first, let's shrink that down. So training wheels on, I'm gonna kind of skim over a little bit of this stuff, but we've got a single hashtag or pound makes a section heading, and a double hashtag, double pound makes a subsection. And then code chunks, we have to start and end them with the triple tick. This is not the quote. The tick mark is on the key with the tilde wave underneath your escape key on the upper left-hand corner of your keyboard by the number 1. So we have to, inside those curly brackets, put the letter R to tell it it's our language. Now, I had written here libraries. That names the chunk. You can name a chunk, you don't have to, it's optional. So in here I have put that I need to check out or make available the 2 different packages, the tidyverse and read Excel. Tidyverse will automatically load 8 different packages that are really core and useful. I always load them. And read Excel package will let us read in Excel files. Now, the code is typed in here. However, if we want to execute it, then we need to run the code. Just having the code typed is not enough. We need to actually run it to execute it, to make it do that thing. And the easiest way is on the corner of these code chunks, there's a little play button. That's the green sideways triangle. There's also a run all chunks above that we're not going to worry about right now. And then there's a gear for modifying the options, and we're not going to worry about that either. So the play button, this little green triangle, when we push that, you'll see over where the line numbers are, it's going to be green. And that's our progress bar going down the code chunk. And as it does that code, it executes and does the checking out of the packages, it may or may not give us some output. And you can see it's mostly mirrored in the console as right under this chunk, because it used to not put the output under the chunk. This is like in the last 2-3 years. It's very handy. But it's telling us that Tidyverse, and this is Tidyverse version 1.3, that's what we're using at this time. When we say library Tidyverse, it is actually checking out, loading, or making available 8 packages. And those 8 packages are ggplot, tibble, tidyr, readr, per, dplyr, stringr, and forcats. I talked about a little bit about those last time. And it is also giving us some conflict information. So this is where the dplyr package has a function named filter, but baseR in stats has a filter command as well. And both of those are going to do something different. dplyr also includes a function called lag, and the base stats package has a function called lag. And so this is just giving us some information. It's not an error that we need to worry about, but it's just informing us that, hey, we have conflicts because we have 2 packages that have functions that are named the same thing. And to make sure you use the one that you want to use, you might want to say the package name, : function name. And I will try to always do that because it teaches you where the functions come from. It conveys to other people which package I'm getting the function from, and it helps me remember. So again, clear page just is a hard page break. So we're going into section C. Now this first 0, item 0, is not in the textbook, because in the textbook you just click on a button to open your data set. But in R, we actually have to read in the data set. Now you can read the text here, but it's all these beautiful colors. It might be easier to read in the PDF version. So I'm going to get the PDF version up. So we've got in section C, we've got problem 0, 1, 2, 3, 4, 5, and 5 has a part A and a part B, and 6. And then we're going to put it all together to finish off this assignment. So here it's giving the information about the Tidyverse package. Again, nothing to worry about. It's just saying, hey. So we can now read this. So question 0, we're going to import the data from an Excel file. We need to read in the data, and the data set is called enos dataset.xls, except for I think this time when we downloaded it, it has a -1 after the eno dataset. And we need to store that data frame with the name or a label and we're going to call it DF0. Since this is question 0 or item 0, we're going to call it DF0. For question 1, our output's going to be DF1 and on through the assignment. And to do that, we're going to use the readExcel function out of the readExcel package, with the only argument we need to list being the name of the Excel file quoted, making sure to include that .xls extension on it. And we're going to do that by using the assignment operator pointing to the name we want, df_0. Okay, no, if we do this correctly, we should not produce any output, but we will see the output showing up in the environment. Okay, so this is the first thing we need to do. So that's what's typed here in our Markdown notebook that then converts to look like it did in the PDF. So here's our first R chunk that we need to put some meat onto this bone skeleton. So, this is here from the last video. I'm going to just delete everything that's in here. Okay, if you've just opened our fresh R, it's going to be empty down here. Highly, highly suggest close R every time you walk away. I mean, not to get a drink or go to the restroom, but if you're going to go on to do something else and you might not come back for several hours or a day, close R. It is not beneficial to leave R and your files open constantly for weeks at a time, even days at a time. It will bog down your memory. So when you're done with what you're working on, save it, and there's the save button, or you can go File, Save, or Save As, but don't try to keep this open forever. It will not do you any favors. Okay, so we're going to do what it said to do here. We're going to name this DF_0, and on that name, we're going to save or assign the data we're reading in. And we're using the readExcel package, its function called read_Excel. And we have to give it an argument, and the argument is the quoted name of the data set, which should be eno dataset.xls. Now that should run. It's not going to, but we learn from mistakes. So I'm going to go ahead and run this chunk by pushing the Run Current Chunk button, and it's going to give me an error. And that's because when I downloaded the file, remember it put the -1 at the end of the name of the file. So this is not running because the spelling or the name of the file is not right. And this is how I check to make sure I'm using the right file names. So it's always good to go to the top of the screen to Session and say Set Working Directory to Source File Location. This just reinstates to R that where this RMD notebook file is saved, that's where it should look for the data. So that's the first thing I'm going to do. And you'll see over in your console, it will produce and execute the code, set working directory to wherever it is you saved this RMD file. Now you can go down by the Help and Packages tab to the Files tab, click on the gear for more, go to working directory. Now you will see, it's like a file viewer, you can see everything that's in the folder where this RMD file is. And I can see that Eno's dataset is there. And it is an XLS file, but notice it has the -1 at the end of the name. I need that spelled perfectly. If yours is not running, check spelling, capitalization, commas, quotes, and pipes. Now we have no pipes and commas here, so things to worry about are spelling, capitalization, and parentheses, and quotes matching up. Now that I have the file name fixed, it should run. Now it ran, but notice nothing came out underneath my code chunk, either in my RMD notebook or in my console. But if we look down at the global environment, it now says data, DF0, has 100 observations with 18 variables. We did it! Congratulations! Pat yourself on your back. You just read in your first data set. Now, that's really great. It says it's in the global environment, but you might want to see it with your eyes. I know I do. And the way that you would see it is to, in a different code chunk, just type the name of whatever you stored it as, in this case, df0. If you play this chunk, if you execute it, when you play that, it will show you a view of your data set. And it says it's a tibble. Tibble is a table of data. It's a data frame, basically. 100 by 18. It's 100 rows, or 100 people, 18 columns, or 18 variables. The first variable is the subject's number. The second is their gender, then their major, then their reason for taking the class, and the experimental condition. So at this point, I'm going to come to our slides. So if I go back to our home in Canvas, and I'm going to click on the octagon that says our class, Stat Foundations. And I'm going to scroll down to where it has the chapters listed in the Getting Started with R HTML slides. And this is the slide 30, where we left off before. So I'm going to go all the way to 30. Okay, there it is. Okay, from Appendix C, we are told that this is our data set. Subject number is the arbitrary ID for each participant. Gender, 1 means they're female, 2 means they're male. So if we go back into R, under gender, we see a bunch of 1s. Now if I keep scrolling down in my data set, I will see a bunch of 2s. So the gender is stored as a DBL. Notice under gender, it says DBL. It's a double floating point decimal. It's seeing it as a number. But we want it to know that it is, in fact, 1 meaning, what's it again? 1 meaning female, 2 meaning male. It's a categorical nominal variable. Major is also a categorical nominal variable. Psychology, pre-med, biology, sociology, economics. They're assigned numbers, but there is no real true order or ordinality to these categories. Same with the reason that the student is taking the stats course. It was either required by their program, they had a personal interest, or their advisor recommended it. Nominal groups. Experimental condition here is 1 is easy, 2 is moderate, 3 is difficult, 4 is impossible. There is ordinality there, but they're definitely categories. So we need to these categorical variables, the main ones I've highlighted here, major, coffee, phobia is yes or from a scale to 0 to 10, the students had to rank how math phobic that they were. And then math quiz, score on the background math quiz. So these are some of the variables that are in our data set. Okay, you can look at your data set a lot of different ways. So we're going to kind of go over these. So it says print the full data, print out the data set, just type the name you stored the data as above. It reminds you df0. Now, I've taken the skeleton and I'm doing the things it says to do in the skeleton. I'm adding the meat to the skeleton. Each time you do something, it's a good idea to try to reknit. Every time you do something in your RMD notebook, knit it. You can do 1 or 2 things, but I would not try to do it all at once. The reason being, if you have a typo or a mistake or an error that comes up, you want to find it sooner rather than later. You don't want to be looking for a needle in a haystack. So do 1 or 2 of these things and then try knitting it and see if you get any errors. If you have no errors, good for you, you can go on. If you have errors, right off the bat, look for the first 5 things. Spelling, capitalization, quotes and commas matching up, parentheses matching up, and pipes either missing or going nowhere. Okay, so here's my PDF. Before, this wasn't here, but now we have the data set printed out. So we have the data set. So we have our what we typed into the first chunk, what we typed into the second chunk, and the output from the second chunk as well. Wow, there we go. Okay, so the next step is to list the variable names, count the dimensions, and print a brief section of the data. So I'm going to keep scrolling down. And we've got our little outline on the side. Now, at this point, it's usually good to use your real estate. I'm going to slide the console and that section over so I have more of my space. In fact, I'm going to shrink this down just a little bit so I can see more of what's going on in my notebook. So to list the variables out, we can use the function names. N-A-M-E-S. It's in base R, so we don't need to say what package it's in. And then we're just going to give it the name of the thing we want the variable names for. And then I can push play. And it's going to list out all the variables that are in the data set. The first one's subject number. The second one's gender, major, reason, on across. Now you'll notice that there are some numbers and some square brackets at the beginning. This just helps you count. So 1 is subject number. So let's count the variables. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 variable names across the top row. Then the 9 here lets you know that this is the 9th variable name. So the inks pre is our 17th variable. So we can quickly see that there are 18 variables without counting them all up. So we can also use that DIM function to ask what are the dimensions of a data set, a data frame. 100 rows, 18 variables. And then one of my favorite ways to view the data is with a function out of the Tibble package that's part of the tidyverse called glimpse. And to use it, we need to just give it the name of the data set. And it's going to print out another way to look at the data. It tells us that there are 100 rows. Remember, rows are subjects. 18 columns, that's 18 variables. And then the $ denotes that these are the variable names. Then next to it, it says what kind they are. And if we notice, all of these variables say DBL. And remember, DBL means double floating point decimal, or a numeric, a number, a continuous value is what it's thinking it is. And so you can see all these numbers. Notice numbers are not quoted. Text and factors are quoted, except for the special NA, which is a blank space holder, and the logicals true and false. And those are all capitalized. NA, true and false, but no quotes. Okay, so on to step 1. We need to declare and label our categorical variables. Okay, so these are the categorical variables in this data set. Remember, we have gender, major, reason, experimental condition, coffee, drinker, phobia, not really numeric, or not really categorical. So just those. Okay, so gender, 1 is female, 2 is male. I've typed it in for you. Major, we've got those 5 majors, the 3 reasons, the 4 experimental conditions, and yes or no whether or not they drink coffee. Okay, so these variables, let's look at the first one, gender. Right now it's stored as 1s and 2s, but it's not really a number, so we need to declare it as a factor. This is how we do it with syntax. We are going to start with the data set that we imported, that df0, and we're going to convert all the variable names to lowercase. Because remember, what are the stumbling blocks? The spelling and capitalization are the first 2. So let's get rid of capitalization and just make everything lowercase. Okay, so I'm going to start with df0, and I am going to use the dplyr package to rename all to lower. And it says right here, it's green in mine, use the rename all function from the dplyr package in the first step. The only argument should be the command to lower, and that's not in quotes. Okay, so if I run that, notice I have the same data set I had before, but all the variable names, see, they're lowercase. Before, gender was a capital G. Gender had a capital G. Major had a capital M. By adding the step, the verb, rename all to lower, and to lower is the how. We want the verb is to rename them. That's what we're going to do. The to lower is the adjective or the adverb, how we want to rename them. Okay. Now, It also says here, connect with pipes. So we're going to add 5 more steps connected with the pipe and precede everything. Oh, let's just add the 5 more steps with the pipe. Okay. 1 step for each variable. So let's take the variables one at a time. Let's start with gender. So dplyr is our data pliers, how to work with the data. We're going to use a function called mutate. Mutate, a mutation. Here we have COVID, and we're talking about the COVID genetic mutations. It changes the code slightly. Or of a DNA is a viral mutation. I used to watch The Simpsons all the time back when I was younger. I know it's old, but there was the nuclear waste that went in the pond, and there was a fish that came up, and the fish had 2 big eyes and a 3rd eye. So whenever I think mutation, I think of that 3rd eye fish. So when we're going to use the mutate command, we are going to create a new variable in our data set. And the new name that we're going to give it for our class is, we're going to give it the same name, gender, but I'm going to add I know that this is breaking my rule. I'm going to add a capital F at the end of the name. That capital F is going to remind me it's the factor version of the gender variable. So I'm going to make the factor version of the gender variable. If I can spell right. So I am going to take my data set, and the first thing I'm going to do is rename all the variables to lowercase. And then, remember that pipe symbol at the end of that line says, and then I'm going to use the dplyr mutate function to create a new variable. This new variable is going to be called gender F, which is a factor version of the gender variable. Now, when I do that, I need to add some options. The levels that were already in there were 1s and 2s, but I need to glue the number 1 and 2 together, so I'm going to use concatenate to do that. 1 and 2. We use commas inside parentheses to separate. And then I want to apply labels to those values. So I'm going to have 2 values, 1 and 2, and I need to label them female and male. Female and male. Now, whatever order the numbers are in, the labels have to be in a consistent order. So I know that 1 goes with female, 2 goes with male. Now, if I run this at this point, it did not do it. Did I spell something right? Wrong, I mean. Oh, the gender variable didn't change. I didn't change the gender variable. I added a new variable called gender F. And whenever you add a new variable, it puts it on the end of the data set. There's my gender F. It now has female or male as text. Now, the quotes don't show up in this view, but you need to quote text when you use it. So that's how we can create a factor version of the gender variable. And then we're going to do the next one. So I'm going to do another pipe. Now the enters are purely for human eyes. The computer does not care where you use enters. But if you push enter and you've got your commas and parentheses right, our studio will line things up very nice for the human eye. Okay, next variable. Let's see. So we did gender. What's the next one? Major. These are my majors. Now I'm going to 1, 2, 3, 4, 5. Okay. So, and then I am going to use the dplyr package to mutate again, and I want to make major factor version. So I'm going to use the factor command, and now that's in base R, so we don't say what package it is. So we're going to create the factor version from the original version major. And right now, the levels that it's stored at, we're going to combine 1, 2, 3, 4, 5. And the labels we're going to attach to them. Oh, we got to quote them because they're text. I got to go back and remember. Let's see. Psychology. And I'm a fan of copy paste. And I'm just using enters because it makes it easier for my eyes to read it. Pre-med is 2. And biology is 3. And sociology is next. And economics is last. Did I get 1, 2, 3, 4, 5? Okay. Now if I run the code, gender and major, the original variables haven't changed. But if I look at the end of the data set, there's my gender variable, there's my major variable. So it looks like the first few people in our data set, at least the first 10, are girls in psychology. And if I keep going down, oh, now we get girls in pre-med. Keep going down, we've got sociology, and then economics. So it looks like this data set's already been sorted with all the girls, the females first, and the males second. Okay. Now on to reason. Okay, so reason. So I'm connecting each new step with a pipe. Dplyr, mutate, and we're going to do reason with a capital F, which is going to be a factor version of the original reason variable, where the levels were a combination of 1s, 2s, and 3s, and we're going to now label these. Again, this kind of stuff is like 80% of the time you spend with your data set, just getting it ready. Now, the good news is as we get this data set ready, and you can use your copy-paste shortcuts. So if you've worked in Excel or Word or any of those programs, on Windows, it's Control-C for copy, Control-V for paste. And on Mac, I think it's the command key, this little fancy key with the C for copy and V for paste. But the good news for you here is that we are going to use this data set for the rest of the semester. So every homework is going to start with this information. Okay, and I'm going to keep going. So we got gender, major, reason. What's the next one we need to do? Experimental condition. EXP_COND with a capital F because we want the factor version of the original experimental condition variable that had levels, combination of 1s, 2s, 3s, and 4s. And now we're going to label that, make the labels so that they are easy, medium, hard, and impossible, but not with a K. Now, you can leave them all in one line. You could add extra spaces. You can take away spaces. You can put enters. That's all human eye issues, not computer. And there's one more after experimental condition. Let's see, coffee. With a capital F is going to be a factor version of the original coffee variable that had levels. That was the combination of what numbers? Was it 1s and 2s or 0s and 1s? 0s and 1. 0 and 1. So we want to label that. So 0 matches with not a coffee drinker and is a coffee drinker. Or regularly drinks coffee. That's how it's defined. Okay, that's the most typing we'll do in any one time for anything in this class. That was a ton of typing. Again, all of this information about which variables have which numbers going to which labels are in the data dictionary in the Appendix C. And anytime you're working with a data set, you've got to get that information from somewhere, either because you have the actual surveys or you know where it came from, or the data set came with a data dictionary. It's really important to have that. So let's see, this girl in psychology is taking this class because the advisor recommended it. They get assigned a medium difficulty condition and they regularly drink coffee. Okay, here we go. So we renamed our variables to lower. We used the mutate command and added the capital F at the end of each variable name to create a factor version. And we did the levels, which were bare numbers, and the labels, which are quoted text. And the last thing we need to make sure is to precede everything with the new data frame's name and the assignment operator. So this, saving it to df1 because we started out with df0. Now this is something different. We're going to call it df1. Okay, now, if you did everything right, when you do the assignment, there's no output produced under our code chunk. But if we look at the bottom in our global environment, we now have data frame 1, which still has 100 people, 100 rows, but now instead of having 18 variables, we have 23 variables because we have these 5 new variables that we created that are factor versions of those categorical variables, so that they're not going to be treated as numbers, they'll be treated as nominal or ordinal values. Okay, so print the data view. It says print the 5 new variables at the end of the data frame. Also check the class of each variable shown in pointy brackets after the variable name. So to do this, I'm going to use out of the Tibble package, the glimpse function, and I'm going to give it the df1. Oh, that should be df1 because df1. Now, view the 5 variables at the end of the data set. Okay, so now remember our original variables, gender, major, reason, experimental condition, and coffee, were stored as numbers. That's DBL. But now if we look down at the bottom of the data set, these new ones we created now have gender with a capital F, major with a capital F. These all in the pointy brackets say their class of variable, they are factors, and we actually see the text being saved, the labels attributable to them. So always when you clean up data, get it ready to do anything with, whether you're making tables, plots, or running an analysis, you want to label and declare categorical variables as factors so they'll be handled appropriately. The next thing we're going to go over how to do is how to adjust in a variable. And sometimes we want to adjust or create a new variable by adding amount, dividing amount, or adding and dividing an amount, or subtracting or multiplying. So mathematically altering a number. So for the second item, we're going to create a new variable that is their math quiz score, but we're going to give them a 50 points onto it. So we're going to create a df2 from df1. So I'm going to start with df1 and I'm going to do something to it. So it's going to flow in a pipe, and I'm going to go ahead and use that dply or mutate command again to create a new variable. And the new variable here, it says make it math quiz plus 50. And we're going to make that by adding 50 points to everyone's math quiz score. So if we look at our data set, math quiz was one of the variables, and you can see the first person got 43, the second person got 49, the third person got 26. So we're going to take that variable and we're going to add 50 points to everyone. So we're going to take math quiz and we're going to add 50 points, and it will do that for everyone in our data set. So we're going to use that add symbol to add 50 points to everyone's math quiz to make this math quiz plus P50 plus 50. And it says we need to save this resulting data set as df2. And note, if we do this correctly, we should have nothing show up underneath this code chunk. But if we look at the bottom in the environment, we have df2 is still the same 100 people, but now we've added an additional variable to it. So it says to print out select data. So we want to print out the first few lines of the data set, but only include the person's ID and their math quiz scores, both the original and now this corrected one. So I'm going to start with the DF2, data frame 2, but if I run that, it's going to give me all this stuff. If I only want to look at the first or some of the variables, I can use the dplyr select command. The dplyr select command lets you select some variables. So I want the math quiz and the math quiz P50. So it's only going to show those few variables, so I don't have to keep scrolling back and forth. And then I can also filter, use the head command. The head command, HEAD, just says the first few rows. So by default, it's going to show us the first 6 rows, but just the variables subject number, math quiz, and math quiz plus 50. Select chooses the variables, and then head just takes the top few rows. So I can see if my command did what I wanted to do. Did I really add 50 to everyone's score? Well, the first person, their math quiz was 43. Now it went to 93. Yeah, that's what I wanted. The next one's 49, 99. Yeah, did what I wanted. And so you can proceed down. I am going to stop this video because we're getting kind of long. We're over 40 minutes. And I'm going to let you guys try the rest of this by reading the directions, and you might find it's easier to read the directions in PDF form. Also, I'd like to remind you to periodically stop and knit. And the nice thing about knitting is it saves both your RMD and the PDF is automatically saved. Remember, where can you find that PDF? In the same folder that you have your RMD and your data set stored. Okay. And let's see what you guys can do with it. That's the hardest part. Although there might be some tricky things. I'd be happy to answer questions either on the Q&A board before the first half hour before class, the first half hour after class, or we can use some class time to discuss this. So let's stop that recording.